Hi, my name is Nehir Defne Alın. I'm a first-year Electrical and Electronics Engineering student at Bilkent University. Today, I will perform my Physics-101 project experiment. My project is about the mass and radius effect on frequency and centripetal force in uniform circular motion, and also about gravity calculation. The main purpose of this experiment is to show how changes in mass and radius affect the frequency, and as a result, the centripetal force in uniform circular motion. Additionally, I will use the collected data to calculate the gravitational acceleration. Equipments are a stopwatch, a string that does not extend, a plastic tube, 100 grams weight, 520 grams weight, a ruler, a paper clip. In the first part of the experiment, I investigated the relationship between the mass of the object, the frequency, and the centripetal force in uniform circular motion. I attach a 100-gram weight to one end of the string and pass the string through the tube. Then I attach a 20-gram weight to the other end of the string. I adjust the string so that the radius of the motion is 30 centimeters. Next, I start rotating the upper mast horizontally over my head, keeping the lower mast in equilibrium. Once the motion stabilizes, I start measuring the time for 20 revolutions. Then I repeat the entire procedure for different masses. In the second part, I now investigate how changing the radius affects the frequency and centripetal force, while keeping the lower mass constant. First, I place the tube at 15 cm radius, then perform the same measurements as before. I then repeat the entire procedure for different lengths of radius. In the final part, I perform additional experiments to collect data for the calculation of gravitational acceleration. In the first table, the frequency and centripetal force were calculated for each case. The relationship between mass of the object, frequency, and centripetal force was observed, aligning with theoretical expectations as the mass of the stable object increased from 100 grams, 120 grams, 140 grams, 160 grams, and 180 grams. The frequency also increased, which then resulted in a higher centripetal force. In plot 1, the centripetal force was found to be directly proportional to mass. The best fit line confirmed the linear relationship that was expected from the theoretical formula. In the second table, the relationship between radius, frequency, and centripetal force in uniform circular motion was examined. As the radius increased from 15 cm to 55 cm, the frequency of the circular motion decreased. A larger radius means the object travels a longer path in each revolution, leading to a lower frequency when the other factors are kept constant. While the hanging mass remained the same, slight changes in the calculated centripetal force were observed, likely due to small experimental errors, such as variations in maintaining a constant radius or timing inaccuracies. Overall, the plot and the table demonstrated that increasing the radius results in a decrease in frequency, and slight fluctuations in the centripetal force, reflecting the expected physical behavior in uniform circular motion. In Table 3, various experiments were conducted in order to collect additional data, and in Table 4, the frequency values were found. With the values of frequency, the relationship between the mass to radius ratio and the square of frequency was plotted in plot 3. The slope of the best fit line was used to calculate the gravitational acceleration. The calculated value of gravity was found to be 8.38 meters per second squared, which deviated from the theoretical value of 9.81 meters per second squared by 14.60%. This discrepancy would be attributed to experimental errors, including timing inaccuracies, variations in the radius during rotation, friction, and difficulties in maintaining a constant rotational speed, and a horizontal circular path. Thank you so much for listening.